We're going to talk about micrometers. Now, micrometer is this big C-clamp looking type thing. And this is the jaw of the micrometer. The arm actually is what it's often called. And you can see the small, actually the jaw in here is where it clamps down on the piece you're measuring. And that, as you can see, you turn this, and I'm turning pretty quickly, it moves very slowly. That's because there's really, really finely cut threads in here. Each thread in there is 1/100th of an inch. So one turn of this is supposed to be 1/100th of an inch. So 100 turns is what it would, complete turns is what it would take to move it in and out that full inch. Now we also on here have the barrel and the thimble. The barrel is the main piece here that's attached to that arm that doesn't move. The thimble is the part that spins on top of the barrel. And we're going to take a look at those pieces here as we go on. Now, because those threads are so thin, it's, like I said, it takes 100 turns, 1/100th of an inch per thread to move this in 1 whole inch. If this were 3 or 4 inches long, it would take forever to screw this thing in and out. So a micrometer almost never has more than 1 inch of travel. I don't have any here, but if you want to measure something larger, what they'll have is they'll have a micrometer. Like a standard 1 inch micrometer goes from 0 to 1 inch. That's all it'll measure. But to measure something larger, they might have what's called a 1 to 2 inch micrometer. And what that is, the jaw on that, the smallest it will go is 1 inch. So it still only has 1 inch of travel. But the smallest item it'll measure is 1 inch, and then it'll go up to 2 inches. Then they'll have a 2 to 3 inch micrometer. So again, the smallest it would go is 2 inches. And every measurement we do with it, you have to start out at 2 inches and add on to that. So this being a 1 to 2 inch micrometer, everything's going to be at least 1 inch, and then you'd add on to it. So just here again is a label. This is just a closer look at that barrel, which is the part that is attached to the arm. And the barrel does not turn. The thimble, as we said, rotates on top of the barrel. And it moves in and out. The edge of the thimble, as we turn it, moves in and out on the barrel. So the first reading we will take on the micrometer always comes from the barrel. And we read the barrel at the edge of the thimble. So where the edge of that is at is where we're going to read it. Now, we said that a micrometer has only 1 inch of travel. So this is a standard micrometer, or a 0 to 1 inch micrometer. So the number of whole inches is always going to be 0 whole inches. The numbers that you see on here are tenths of an inch. So this edge here is past the 3, that is 3/10. Now, if you recall yesterday, we looked at the Vernier caliper very briefly. You'll never be quizzed or tested on a Vernier in here. I just wanted to expose you to them so you'd seen them. But on the Vernier caliper, between the tenths, we had the quarter marks. On a micrometer, you will almost always have quarter marks. So this here, I'm going to erase some of my little scratchings here. This here is 0.2 inches. This is 0.225, 0.250, 0.275, 0.3. So think of it as being read in thousandths. That's 200 thousandths, 225, 250, 275, 300 thousandths, 325. So here we're past that 25 thousandths. So it's 325 thousandths is the reading off the barrel of this micrometer. Now we read the thimble. The thimble has this number scale that wraps around it, as you can see. We read the thimble at the axis of the barrel. What number lines up with that axis? What's the 15? Exactly. So that is 15 thousandths. So this is 0.340 inches, which is what the little example says over here too. Now, one of the problems I have with the presentation I'm going to show you is that most of these on the barrel or on the thimble have a line that exactly lines up. That's not always the case. For a standard micrometer, we just go to whatever one is closest. So if it were, if the barrel were lining up, let's say the axis of the barrel was lining up right here, we would still say 15 because it's closer to the 15 than it is to the 16, right? Unless there's a Vernier scale. Towards the end of class, we're going to look at Vernier scaled micrometers. And those we always round down no matter how close it is to the next number up. We will always go to the smaller one because we're going to add the Vernier scale to it. And we'll explain that when we get to it. So let's look at some examples here. This is the inch micrometer. This is our main scale. Of course, how many whole inches do we have here? 0 whole inches, yes. Remember, we said always 0 whole inches. You got it figured out, or you got a question?
No. I was wondering if the ones that we bought go to the 10th spot. The 10,000 spot.
Oh, you got digital ones, or?
No.
It's just like this.
Oh yeah, if they go to the 10,000, if they go to the 10,000s or to the 10th, they have to have a Vernier scale, unless it's a digital. You do have a Vernier scale?
The lines.
The little lines up above here. Yeah, so they'll go to the 10,000s. Yeah, they'll go to 10. Yep.
Okay, tenths and 10,000.
Tenths and 10,000ths and machine talk are the same thing. Yeah.
But tenths.
This is really a tenth of an inch. If I say a tenth, I'm really talking about a 10,000. If I say a tenth of an inch, then I'm talking about a tenth of an inch, 0.1. Yeah. So here, what do we get in tenths of an inch? 2, right? Do we have any quarter marks? 1. So this is 225. Now on the barrel, 15. So this is 0.240. Not so bad. Not quite so bad. There. So here, whole inches. 0 whole inches. Tenths, or tenths of an inch. 4. Quarters. Are we at that quarter? We see the edge of the line. Well, yeah, we're exactly at 0 here, which means we are exactly at that quarter. So that's it, 0.425. How about here? Where do we start? Are we at the 0.8 or are we at 0.775? Just hit the 0, so we're exactly on the 8. This is exactly 0.8 inches. Do I have to have those zeros on there? It's best if I do. Because if I just put down 0.8, somebody might look at that and say, well, it looks like we only measured to the 10th of an inch. We actually did measure to the 1,000th of an inch, and it came out to be exactly 800 thousandths. So how about this one? Where are we going to start? I'll give you the 0. 975. Then 5 more thousandths from the barrel, from the thimble. Everybody see where I got that? This is 9, 25, 50, 75. And then 5 lines up here.
One that got me already was 0.9, and then it was before the quarter mark, first quarter mark.
Oh, right in here?
And it was 4 on the other scale.
Oh, so you got to make sure you get enough zeros in?
Yeah.
We'll look at one like that before we're done here. So like this one here. Is it 0.6? No. We're not quite back to the 0. We're at the 24 here. We're not back to the 0 yet. So this is 0.575. On the barrel, it is 24 thousandths. This is 0.599 inches. This one here, 0.625. 0.6 and past the first quarter, and 001. So that's 0.626. How about this one? 0425, 425, and 009. So now on this next one, I'm going to tell you that this is a 2 to 3 inch micrometer. So on the arm, on the top of the arm, like on this one, you can see on the top of the arm, probably not on the screen, but you can see on the top of the arm up here, it says 0 to 1 inch. Well, for the one that we have here, this is 2 to 3 inches, what it's labeled across there. So what that means is the smallest it goes is 2 inches. So all of my measurements, instead of starting at 0 inches, are going to start at 2 inches. It'll be 2.725. Everything else works the same, right? 725. And on the thimble, 22. So it's 2.747 inches. This one here, I'm going to tell you, is a 1 inch to 2 inch micrometer. So where's my measurement start? 1 point. Yeah, we're not quite back to 0 yet, so we're not quite to the 9. So this is 875. 825, 50, 75. And then over on the thimble, it's 23,000, so 0.023. So 1.898 inches. Any questions on that? So for this one, it is 0.325. Good. I didn't say anything about being a 1, 2, or 2, 3, so we're assuming it's a 0, 1. So 0.325, and then off the thimble, 13, so 0, 1, 3. So 0.338. Now we will come back to your question there, Joss, about where it's just after and it was less than 10 thousandths. But I'm going to go on. I'm going to finish up the PowerPoint here, then we'll go to the simulators. What this is here is this is an inside micrometer, often a depth gauge, basically. And an inside micrometer still has the same scale over here to read, but we can't, we need to get length in there. You can see this bar here is labeled 3 to 4 inches. That's a 3 to 4 inch bar. It is saying that this measurement starts at 3 inches. So I know this measurement starts at 3 inches. Now this is going to read exactly. Now the depth gauges like this, the inside micrometers, only go up to 1/2 inch. They don't have a full inch of travel. And I'll show you, that's an important thing. I'll show you in just a minute. So it starts at 3 whole inches. How many tenths? 2. Any quarters? Yeah, 1/4. So 25. 225. Off the thimble, 20 thousandths. So this is 3.245 inches. This one, it still says 3 to 4 inches here. Do you see anything that looks different between those two? Do you see it? Little piece here, right?
Yeah.
That's a 1/2 inch extension. So what that is saying is this doesn't start at 3 inches, it starts at 3.5 inches. Then what's red here goes on to that. So this is 325 off the barrel. Off the thimble, 12. So this is 3.837 inches. Because these only go up to 1/2 inch of travel, we have to put those 1/2 inch extenders there. If it's beyond a 1/2 inch. So the first thing we gotta do is figure out where it starts. Where does this one start? 2 or 2.5? Just 2. Now, since it's not a 1/2, I can go ahead and just put my tenths right in with the 2. So on my tenths, I have, or no, yeah, my tenths of an inch, 3, and then it's 50 for 2/4, right? 350. What's on my thimble? 24 thousandths more. So 3.374. 2.374 inches. How about this one? Where does this one start? 3.5. Now, because I have the half in there, I've got to put a separate line now for my barrel. My barrel reads what? 125. 1/10 of an inch plus another quarter. And on my thimble, 10. So 3.635 inches. One last one here. Where does this one start? 4.5. Barrel, 475. Thimble, 24. It's 4.999 inches. This is a metric micrometer. The reason I can tell is these are no longer labeled 1, 2, 3, 4 anymore. They're labeled 5, 10, 15, 20. So these are millimeters. This is 15 millimeters and 20 millimeters. Metric micrometer is labeled in millimeters and halves. You can see here, if I were to count up, this would be, come on, 16, 17, 18, 19, 20. Well, these marks here are the half marks. So this is 15, 15 and a half, 16, 16 and a half, 17, 17 and a half, and so on. So when we read these, we read whole millimeters and halves if we have to off the barrel. So this barrel is 21. We see the line. We look here. We've just passed 0, so we know we've just passed the 21 whole millimeters. This is hundredths of a millimeter. It goes from 0 to 50 because we could label our half of a millimeter on the barrel. This right now is at 5, so that is 0.5. It's kind of like what you were talking about. You've got to make sure that you don't just put 0.5. It's 0.05 because it's hundredths. So this one, where am I starting? 15, 16, 17, 18.5. So 18.5, and then what am I adding on to that? 45. So it's 18.95 millimeters. So tell me what to do here. 6, 7, 8.5. But I'm hitting a 0 here. If I looked really close, I could probably see the edge of a line there. I'm clearly past the 8.5. That 0 on the thimble is telling me I am right at one of the lines on my barrel. I cannot be right at the 8.5 because I can clearly see I'm past the 8.5. So this must actually be exactly on 9.00 millimeters. 50, because that's 50 hundredths or half of a millimeter, and the barrel goes to a half millimeter. So 50 would take it up to a half. Well, then you go past the half point, and then another 50 would take it up to the next whole millimeter. So on the barrel here we have 11, 12, 13, 14. On the thimble, 0.03 millimeters. And this one, 16, 17 and a half. So 17.5, and then on the thimble, 35. That's 17.85 millimeters. So that's our standard ones. Anybody have any questions so far? So the big thing is being able to look at it and first determining if it is a standard micrometer or a metric. And again, the way you do that is you can tell if it is labeled in ones or fives. If it's labeled in fives, it's definitely metric. It's in millimeters. If it's labeled in ones, we are looking at a standard. So looking at this one, is this, that's not what I want. Would this be metric or standard? That's metric. Those got to be in millimeters there. What would this reading be? 10, 11, 12.5 plus 40 would be 12.9. What I want is a simulator. There we go. So this one here, first of all, I'm not even going to open the jaw. From the thimble, can you tell me whether this is metric or standard? This is metric because it goes 0 to 50. Technically 0 to 49, then it starts over at 0. But metric goes from 0 to 50. Standard only goes from 0 to 25. So let me open this thing up a bit. And normally I hide the bottom down there so you can't cheat and see. By the way, what you're seeing here, this is 1.5 plus 42 is 1.92 millimeters. We're actually 7/10 of the way past. Now we don't have a Vernier scale on here, so we can't tell how far past we are. But you can see here, the way I would actually read this one, I don't know if that's large enough. Yeah, it's large enough, you can see. We're past the 42, but we're slightly closer to the 43. So I would read this as 43 hundredths off of the thimble. So I would read this as 1.93 millimeters. This one here, this is 2, right? Point, I'm between 12 and 13. Which one's it closer to? This is the 12, that's the 13. We're slightly closer to the 12, so this is 2.12. Now to get similar to Josh's question, might have one like this. This is 3 whole millimeters. We've passed 0, so we're definitely past the 3. What am I reading here? 5, 6, 7, 8. We're between 8 and 9. Which one are we closer to? I'd say we're closer to the 8. So this is 3.08. See if this is the one I want. Ooh, yes. Actually, not quite. Okay, metric or standard? Standard. So here I believe is what Josh was talking about. Clearly past the 2, right? Just past 0, so we must be past the 2. So this is 0.2, right? No quarters, so this is 0.200, 0.200. What am I reading here? Between the 8 and the 9, it's closer to the 8. So this is 0.208. So here, what are we reading? 0.225, right? 225, 0.225. We're between 15 and 16, but this time it's closer to 16. So we'd put 16, so 0.241 is what that would add up to be. Those making sense so far? Now you can see down here this is saying 0.240, and that 7 means 7/10, so 0.2407. But we can't tell that that's at 7/10 because it's not divided up. So we have to go to the nearest mark, which would be the 241. However, on this one, there is a Vernier scale up here. This one actually lights up because you can't for me, Vernier scales, like I said yesterday, I have to tip them and look down the lines to see how they line up. But this is similar to what we were looking at before. You know, this is 125. On the barrel here, so 0.125. This is between 7 and 8. So we're clearly past the 7. The question is how far past the 7? That's where this Vernier scale comes in. We see which one lines up. It's the 3 here that lines up on our Vernier scale. So what that is telling us is that we are 3/10 of the way between the 7 and the 8. So this is 0.125 plus 7. So 0.125 plus 7 is 0.132, right? 3. This just puts a decimal point on the end. That's the 10,000ths, or the tenths that goes on the end. So 0.1323 from the Vernier scale. So here, this is 0.175. This is between 8 and 9. Now before, when we didn't have a Vernier scale, we went to the one that was closest. This is clearly closest to the 9. But because we have a Vernier scale, we always go to the smaller one. The reason is the Vernier scale tells us how close we are to the 9. We have to start at the bottom and use the Vernier scale to build up towards the 9. So this is 175 plus 8 more is 183.183. And what lines up on our Vernier scale is the 9. So we put a 9 in the 10,000ths place. So 0.1839. Is that making sense? Any questions? So these are the ones you have like this?
Yeah.
Okay. It's been a while since I've actually seen a real one with a Vernier scale. They cost a little bit of money. They're kind of pricey. So how would this one read? 0.225, 0.006, so 0.231, 3. So 2313. How about this one? 0.275 and 4, so 0.279. That lines up exactly, so there is a 0 goes at the end there. This one, 0.300, there's no quarters. 0.9, so 0.309, I put an 8 on the end. Perfect. How about this one? Try not to look down here if you can. Are we past the 4?
Yeah.
Yes. We just passed 0. So this is 0.400. No 0.1 even. We're not even to 1. So 0.4007. So that one's going to be kind of a tricky one to read. Anybody have questions on these? Anybody need to see more examples? Okay, let's see if I can find which one of these is my... I'm pretty sure this is a quiz, not a... It is. This is the metric with a Vernier scale on it. What is this one reading? Well, this is 20, 21. Or would that be 21.5? This is 20, or 20 and a half. This is 21. 21.25, 6, 7, 8. Not to the 9, so it's 28. 21.28. The 8 goes on the end. I don't know if that's French. Stefanelli is French, isn't it? Or is it German? Okay, so here's my simulator for the metric with the Vernier scale. So read this one for me. One, two, 3 whole millimeters. 5, 6, 7, 8. Was it 7 or 8? It's Vernier, so we're always going to go to the smaller one, 7. So this is 3.07. And then we put the Vernier digit on the end, which is another 7. 3.077. By the way, when you're reading numbers in a foreign language, they use a comma instead of a decimal point. So this is what we would consider 3.077. I don't know, in Mexico, do they use a comma or a decimal point? Don't know. What's that? Okay, I'm sorry. Arabic? Do they use the decimal point or comma? They use it. They use metric, so they use a comma. Okay. Sorry. So this one here, let me get to a decent spot. Right there, read that one for me. Not 625, but 650, yep, 6.5. 17, yep, so 6.5 plus 17 is 6.67. And the Vernier digit goes on the end. So 6.675. What's that? That comma is a decimal point. Remember, we just mentioned that a lot of foreign countries use the comma instead of a decimal point. That's why when you write out numbers, you're seeing this happen more and more. Instead of using like 3,120,000, you're just seeing this. I'm exaggerating, but they're just using an extra half space instead of putting in the commas. We're kind of switching over to an international notation. We don't use the commas because we don't want it to be confused in other countries with a decimal point. Especially if it's something like 13,200. Is that 13,200 or 13.2? So we've started using that extra space. It's actually just a half space. Okay, in your books, there's a lot of pages here. Starting on page 297. What's that? This is the big book. Starting on page 297, it's exercise 10.7. Page 299, exercise 10.8. Jumping up to page 307, exercise 11-2. Page 309, exercise 11-4. Page 311, exercise 11-6. And page 313, exercise 11-8. Let me just confirm that these are the right pages for this edition quick. Yes, these should be the right pages. So the first couple of pages go back over the calipers a little bit. Look at Vernier scales. Then they jump into the micrometers. If we need to talk more about Vernier scales on the calipers tomorrow, we will. Okay, have a good one. We'll see you.